Hello, everybody, and welcome to the explanation of homework 6. So this week was about functions. Functions, they typically get some input, and then they also typically give us some output, but sometimes they don't really need any input, and sometimes they don't really produce any output. So let's take a look at some basic functions, or the ideas behind functions. So exercise 1, create a function that takes an integer as input and returns its factorial. So factorial from math class, we know is this kind of a function that, for example, you give it a 5, and then the factorial of 5 is 5 times 4 times 3 times 2 times 1, right? And then we use this function to print the factorial of 10. So here I already gave you the code for the head of the function. So define, so the function should be called calculate subfactorial. It will take one argument, and then here you should put your code, and then it should return the factorial of n. I mean, this is my name of the variable, right? With this variable, I will do something here. So how do we go about it? There are many different ways. Of course, there is a factorial function in Python, but that's not really what we care about here. This is like a nice example to practice the idea of a function. So factorial. So now we need to think about mathematically. So factorial is a function that is defined for any non-negative integer. So it's defined for 0, 1, 2, 3, up to, well, forever, but only for integers, and they have to be non-negative, so not -2. Also, the smallest value of a factorial is 1, right? A 0 factorial is defined as 1, 1 factorial is 1, 2 factorial is 2, 3 factorial is 3 times 2 times 1, that's 6, and so on. So one way how I did this is, so I distinguish between the case n equal to 0 or larger. So if n, okay, so first I defined factorial n, my variable, as being equal to 1, okay? So if n is 0, so if somebody wants a factorial of 0, then I know the value is 1. And so what I do here is I put here this pass. Pass means do nothing. So, normally you would put here, if n is 0, I don't know, print or do this or that. You have to do something. You have to put there. You cannot just make it empty. Otherwise, Python would not be happy. Let's try that. Right? Expected and indented block. So I just don't like it. So if we put pass, that just tells him, well, just, pass. Do nothing. Go on your business like nothing happened. So if it goes for this pass, then, so if n is equal to 0, then this pass happens. We skip the other part, and we get all the way to the end, and it gives return and gives factorial n, which I already defined here as 1. So that is a correct answer, right? Else, so if n is larger than 0, then how I'm going to produce the factorial here is using a for loop. So I'm going to take a for loop that starts from 1 and goes all the way to n and included. And in each step, I take factorial n and I multiply it by the number in the range. So I'm basically, what I'm doing is I'm doing 1 times 2 times 3 times 4 up to times n. Right? In each step, I do one multiplication and I save it here. So that's what gives me the factorial. And now I put print factorial n equals to 10, and that's what gives me this result. One important thing you should think about is, so what if I put here I don't know, what if I put here 2.5? Right? What would happen? What if I put here 2.5 or -8? Right? What would that do? And what could I do about this code here, or what should I do about this code here if this happened? Okay. So next example is creating functions with multiple arguments. So first, create a function that takes two real numbers as input and returns their product. So again, indeed, such function exists in Python, but we wanna practice here. So again, I give you a name. So the function should be called calc sub product. Takes two inputs. We store them in x and y, and we want the function to return to us the product of the x and y. So if you look at the solution, so well, it's pretty simple, right? I mean, a product of x and y is just x star y. Now we could have stored it into some variable like product of sub x and y, and then do it here, right? Do like a product, put x star y, and then return product. We can do that, but actually we don't have to. I mean, on this return, after this return statement, you don't really need to put here just a single variable. You can put here a whole expression that gets that is about to yet to be evaluated. So here you can put a whole equation that, as long as it can be evaluated at this point, it will evaluate it, and then it will return the value. It will not return the equation, it will return the value. Okay, so that's easy. Now create a function that takes an arbitrary number of real numbers as input and returns their sum. And I put here a note, learn about star args. So what if I have a function called calc sum, or I want to calculate a sum of a bunch of numbers, but upfront I don't know. Some people need to sum 2 numbers, some need to sum 10 numbers, people need to sum 100 numbers. So how do I make a function like that, right? Definitely if I give it a variable x and y that has 2 inputs, right? But here I don't know upfront what is the number of the inputs. So for that is good this star args. So if you give it this star args, it allows you to pass a variable number of arguments. So here I do it like this. Now this basically, I mean, it can be all sorts of types. I mean, it can be an array, it can be also like a tuple or a list or lots of them, but it's not expected. It's not upfront known how many of them is there, and you can access it, in a pretty simple way, just through iteration. So now I do the sum. So well, easy sum is again using a for loop. So this is some kind of iterable variable. So I just go through it and I just add each guy together, right? So I create here a sum. I call it add. In the beginning, I say that the sum is a 0, and then I do a for loop for arg in args. So here I don't put the star anymore. The star here is to kind of show that this will be the non-predetermined number of variables. So for args in args, add every arg, to the add. So in each step, I add each member of the args and I sum them up all, and then I just give return of the sum. And so you can see, if you run this code, you will see that you can put as many arguments as you want. Very little, a lot. Actually, you don't have to give any argument. You will not get a problem with giving no argument either. Okay. A simpler version of this function is simply, I mean, there is a function called sum, right? But maybe you don't want to, you need to rename it or whatever, so you can do it like this, or you use it like this. Okay. Here I have just add a little bit on the previous thing. So sometimes, what if you wanted some fixed number of arguments that inputs everybody has to put, plus then they might put some extra. So as you can see here with the args, it's okay to give none, but maybe you want at least some minimum. Everybody has to put at least something. So here I said, you have to give me three. It's a fixed number of arguments. You have to give 3, and then some extra, and that's up to you whether 0 extra or 100 extra. So this is how I can do it. So you can mix this idea of, fixed number of arguments and kind of these variable arguments, and then, well, you just fix the code here and then it works fine. Okay. Next is, so now we have a function, and so up to now always our function was giving us back only a simple argument. So how about we make a function that gives us more than one argument back? So I want a function, I give it 2 numbers, and it should give me back their sum, difference, and product. And so the most easy way is, like I said, after return, you can put expressions that are yet to be evaluated. So here, this is a sum of 2 numbers, this is a difference, and this is a product. And if you just separate them with the commas, basically the function gives you back a tuple, means it gives you these 3. So you can also get them out of the function using a tuple of variable names here, and and you can work with that. So you call the function once and you get all sorts of different outputs. Okay. Now a really important and interesting thing is about variables inside and outside of the function. So here I gave you some code and I wanted you to take a look at it. So let's take a look at it. So it defines a function called swap, and it has 2 variables, a and b. And so what it does is it stores a in a temporary variable, then it puts a equals to b and b equals to the temp. So now the values of a and b are swapped, right? They're changed. And well, but that's it. The function has no, it has no clear outcome, or it doesn't return to us any value. Just I gave it to 2 values, I swapped them, right? And so some might think, or you might think, that if you define these here, a variable a equals to 3 and b equals to 7, and you call this function swap on them, that what happens is that this function swaps a and b. But if we run this, as you can see, nothing has happened. And there is a very good reason for that. And that is because there is something called a global variable and a local variable. So global variables are the variables that you introduce here in the global part of the code outside of any function, and they are accessible anywhere in the code, including the functions. However, whenever you define a variable inside of a function, that also includes here in the definition, in the head of the function, these are called local variables. Okay, and even though here we used a and b, and here we also used a and b, Python don't think these are the same. These are a and b global for him, and these are a and b local. And I can make another 100 functions, and they all can have a local variable a and b, and Python will not mix them. Always he goes into the function. And so the thing is that also what happens is when you call the function here, you're not really giving it a or b per se. You are often giving it the value of a and the value of b. So now it stores here the value, this value of this a and this b into these a and b, and then it works with them. But it does not necessarily work actually with the pointer. So it does not really work with the global variable. I mean, here what we can also show, so you can see that actually the swapping, it happened. Print AB, right? So you see it shows first 7, 3. So you see the function actually worked. It got 3 and 7, and then it changed it to 7 and 3, but it did it it did it only locally, not globally. So it had no influence on these guys out here. So you have to be careful about this. So sometimes one wants to pass the global variables into the function and so on. So for example, like if we wanted to have this function that gives us the exchange, so we have to think about it, how we do it. So let me show you a few ways how to approach this. So here, what we could do in this swap function is, so it takes the two values, a and b, and we want to, well, swap them. We want to give them back in an opposite order. So what you can do is you can make this function to return the swapped values, a and b, right? But then you define a and b, and then you, into a and b, you assign it the swapped a and b. And this is going to now work. Now, what you have to realize is, so now what I'm doing, so I'm reassigning these global variables, right? Because these are immutables. These are integers. We talked about it. So these are immutable. They actually cannot be changed. But for the variable, I am just reassigning it with the new values, and for that I use the return of the swap function. So this will work. Actually, this function can be made even much easier, right? I can just, given values of a and b, I can just return the values b and a, and it's gonna work exactly the same. Now, so here basically what we did is we reassigned the global variables, outside of the function. The function took the values, did something with the values, and then here we just reassign the global variables with the values outside of the function. Sometimes you would really want the function to not to give anything back, but kind of, deal with the global variables. So one way how to do it is, we talked about these mutable variables. So for example, an array, right? A NumPy array is mutable, right? A keeps one array, but you can change the values inside of the array, no problem. And so then you can use this kind of function. So you can give the function swap, you can give it the array, and then here you can swap the values within the array. And so here you are really not giving this function the values of the array, but you're really giving it a pointer to the array. So this is going to work pretty well, right? So this is array 3, 5, and you see the output is 5, 3, where I changed. So that is because A is an array which is a mutable object, so we can change it. We can reach this globally defined object. We can change it, right? Because it's changeable, so we can change it within the function. Okay. Another way how you can do it is you can declare global variables within the function. So here again is the same example as before. A is 5, B is 3. So now what I can do here, so I don't actually need to give anything to the swap function, but here I do this global, I write this global in front of A and global in front of B. This allows me to access A and B as the global variables, okay? And now I can change them. So here now I'm going to doing the change, and now if I call the function swap, this is going to do what I want from it, right? It gives me again 3, 5, even though it was 5, 3, because now this function did not use its own local variables A and B and did something with them. No, I told it, okay, you are allowed to touch the global A and you are allowed to touch the global B. Now you can touch them and do stuff with them. Actually, this here is necessary only when you want to change the variables, when you want to change the values of these global variables. If you just want to use a value of a global variable inside of a function, that's all right. So of course, you should not declare a local variable of the same name. Of course, I cannot have here A. Okay, then if I did print A, it would print this A. But if I have here only, let's say B, I can do something with B. I could do here A star B. Okay, print A star B and B give 2. Okay, now I'm gonna run it. So I created this new function. I call it printo, right? It's just print function. And so you see, I gave it a value B, that's 2. And this function, what it does, it prints A times B, where A is a global variable. So if you want to just access it, just so you want to read it, you know, you need it like some kind of a constant like pi or something, that's completely all right. There's no problem in accessing it. But of course, you cannot have a local variable of the same name, right? So if I put this A, and then I did this one, this would be A, and now I run this, it did give me no error, but it just gives me 4. It just thinks, okay, local variable is A. So when I do A star A, it accesses the value in this A. It does not go into the value of this A. Okay. And so the last one is the exercise to well, use functions for what actually, I mean, they are used. So so the main, I would say the main reason, right, why we use functions is to kind of have a nice concise code where if we need to repeat something, if we need to do the same thing all over again, we don't want to be rewriting the code all over again. I mean, there is a high possibility of making mistakes and so on. So we create functions so we would have a piece of code ready for reuse at any given time, right? So that's why, for example, I create this function factorial. I mean, everybody can make their own factorial, right? Everybody could make their own function print and so on if they want it every time they start Python. But well, first of all, it would be an extra work. They would have to work on it. And second of all, I mean, if you want to calculate factorial 5 times in your code, you know, rewrite this whole code 5 times is just, you know, I think you see that there's a good point in, you know, having it concisely like this, and then every time you just call it, you just call the function. So that's the same thing that we do here. I mean, if we look at this code here, we wanted to create these 3 graphs for linear, sinus, and exponential. And if we look at this, I mean, there's lots of things they're repeating, right? I mean, here assign the function. Okay, that's those are values. That's different for each. But then here I call this plot function, and I give it some values, right? And then I call set label, and then I call set y label, set x label, and then I create a legend. And so this whole piece of code, if I look at this, it repeats. It's same here, it's same here, it's same here, except the values I give it, right? The inputs I give, they're different. But so why not to make a one function that will do all of these? You just give it these inputs and it will do all of these for you. And so that's what you were supposed to do. So I create here this function, I call it a graph. It gets all of these inputs, and then just puts all this code and just puts the respective inputs into the code. And so now immediately you see, for me, the rest of the code here is much clearer and, you know, easier to understand, and it's more uniform. I mean, because I want to plot same looking graphs all over, so this, you know, helps me to make things more nice. All right, that's all for today. Thank you.